Welcome to this course. My name is Stephen Hancock, and my voice will be the voice you hear throughout the course. The purpose of this course is to cover 11 JavaScript features that I feel are critical to understand. Now, why 11? Well, I started this process by listing what I thought were the most important features. Then I reviewed similar lists from other JavaScript developers. Those that showed up the most and weighed the most in my mind made the list. The final number ended up being 11. So let's look at those 11 topics which we are going to cover. So first off, we're going to deal with scope. An important topic for any JavaScript developer to understand. And then we'll talk about hoisting. Falls along the same lines as scope. Then we need to talk about the fact that objects in JavaScript are everywhere. They're a big part of JavaScript, and you need to understand that in order to be effective in JavaScript. After that, we'll jump into prototypal inheritance. Understanding how inheritance and how objects share properties and methods in JavaScript is critical. From there, we'll go to higher order functions, a concept in JavaScript that makes many things we do in JavaScript possible. So we want to talk about that. One of the things that are possible because of higher order functions are callbacks. And this is a very critical pattern in JavaScript. You need to understand how callbacks are used and when you can use them. From that, we'll talk about immediately invoked function expressions. A structure in JavaScript that you'll use and see in a lot of different code. Finally, we'll talk about closure. One of the concepts in JavaScript that I think is probably one of the most important concepts or features of JavaScript. Closure. Then we'll deal with the module pattern. A pattern you'll see throughout JavaScript, a pattern which is important to understand. We then need to talk about this. This can be something that can be a little bit difficult to understand in JavaScript when you're working with objects. So we need to spend a little bit of time on that. And then for the 11th topic, we will deal with promises, a very important asynchronous pattern in JavaScript. So those are the 11 topics. Let's go ahead and get started. It's important to understand scope in JavaScript in order to understand what your code is doing and in order to take full advantage of all of its capabilities. In this video, we will use several examples to help illustrate scope and the scope chain and make that concept more understandable. In this discussion, we'll focus on the keyword var and how it affects scope. And then we will look at let. And we'll do that in the next topic. So first, it seems important to define scope. Scope is simply a set of rules that determine where within a program you can access referenced items. Usually that refers to variables. So scope is a set of rules that determine where you're able to access the variables you have declared. Now, scope isn't limited to variables, as you will see in our examples, but we usually think of variables when we're talking about scope. Let's now take a look at a few concepts that are associated with scope. Number one is scope is determined lexically. Now, what does that mean? Well, that simply means that when you're writing your program, where you place declaration of variables and functions determines scope. So it has nothing to do with when a function is called or when your code is executed. Scope is determined by how you write your program. Second, JavaScript uses function scope. When a new function is declared, that creates scope. Everything in JavaScript starts in the global scope, but as you begin creating functions, that creates scope as well. And then finally, nested functions. So if you declare a function inside another function, that creates a nested function. that creates what we call a scope chain. We'll explain what a scope chain is as well. So these are the three concepts that are important to keep in mind as we go through these examples. Now let's take a look at the code that we're going to use for the examples that will help explain scope. First off, we declare a variable. We assign the number 10 to it. Then we have a function that we've referenced with add 5. Both of those are in the global space. Inside the add 5 function, we declare a variable, assign a number 5 to it, then we log the information that it results from the number passed in plus that variable. We declare another function inside the add 5 function. In fact, we declare a second function, add 15, which is inside the add 5 function. Both of those are called, and a number is passed into those functions. So now let's take a look at what scope is created as a result of this code. Here's a diagram identifying the scope that is created by the code we were just looking at. So the outermost scope I've labeled A, and then the add 5 function creates scope. I've labeled that B. Inside of the add 5 function, we have an add 10 function which creates scope. I've labeled that C. And we have an add 15 function that creates scope. I've labeled that D. Now notice in the scope for B, C, and D, it does not include the definition of the function as a part of its scope. It includes the variable that is passed in, but the function actually resides in the outer scope. For example, if we take a look at C, num2 is a part of scope C, but the add 10 function is a part of scope B. Now let's walk through the code and see how the scope affects what happens. So first off, the arrow is pointing to our first executable statement, which is simply defining a variable A and assigning the number 10 to it. The next executable statement is the calling of the add 5 function, and we pass in a number 3. So we go to the add 5 function. That is where the num variable is declared. So num now equals 3 because of that value which we passed in. We then declare a variable B and assign 5 to it. Now we encounter the console.log statement. Now this console.log statement causes a lookup for the two variables, num and B. First searches for num inside its own scope. It finds it inside its own scope and therefore returns 3. It then searches for the variable B inside its own scope. It finds it and returns 5 and then prints out the number 8 because 3 plus 5 is 8. Now we go to the next executable statement that calls the add 10 function, and it passes in a number 3. So at the add 10 function, num2 is assigned a value of 3. We then go to the console.log. The system searches through its own scope, the scope for the add 10 function, to find num2. It finds it and returns 3. It then searches for A. It cannot find A within scope C. So it goes to the next most outer scope. This is the scope chain that we talked about. The next most outer scope is B. It looks for the variable A within scope B. It cannot find it. So it goes further up the scope chain. It goes to the next most outer scope, which is scope A. And scope A happens to be the global scope. So the scope chain stops at the global scope. If A is not found at the global scope, then it is considered an undeclared variable and causes an error. However, it does find A in that scope. It returns the value and then prints out 3 plus 10, which is 13. we move to the next executable statement, which is a call to add 15, and it passes in the number 3. Num3 is declared with a value of 3. A variable c is declared and assigned a value of 15. And then the console.log statement first looks for num3. It finds it within its own scope and returns a 3. It then searches for c. It finds it within its own scope and returns a 15. Adds those two together and prints out 18. The 4 different scopes which we took a look at here were created by how we entered the code. Because we nested functions inside of the add5 function, that created scope inside that, and also created a scope chain, which it could traverse to find variables when it's looking for them. Now, really quick, what if we were to change a line of code? The bolded line is the code that's been changed. Instead of referring to variable a, it is now referring to variable c. So is that possible? Variable c is actually declared within scope D. Scope D is not a part of the scope chain for scope C. Therefore, an error would be produced. Basically, what would happen is it would look for the variable c within scope C, could not find it. It goes to the next outer scope, which is B, can't find it, then goes to scope A, can't find it, generates an error. All right, one more example with changed code. So that line is changed back, so the variable A is being used. But down inside of function add 15, we change the console.log statement to simply call the function add 10 and pass in a number of 3. Will that work? Well, when that function is called, it will look for the function inside scope D. It will not find it. It will then go to the outer scope, which is scope B. Can it find it there? Yes. The add 10 function is declared within scope B, so it finds it and executes it. Now, before finalizing this video, I like to verify everything we've talked about by executing the actual code. So let's do that now. All right, here's the actual code. It's attached to this HTML page. So when it executes, we should get 8, 13, and 18. I will refresh that, open up the console, 8, 13, and 18. Now let's quickly make the changes which we talked about previously. If I change that variable to C, as I mentioned, we would get an error. Jump out, execute it. Sure enough, we get a reference there. C is not defined because it cannot find C in its scope chain. Let's change that back to A. And now let's call, instead of console.log, let's call add 10. Pass in a 3. So if this works, we should get 8, 13, and 13. And sure enough, that's what we get. One more comment before we leave the concept of scope. ES6, ES 2015 introduced a new keyword for declaring variables, let. That creates a different scope than var. Let is what we will be talking about in the next topic. So let's move on. The ES6 standard provided a new way to define variables. So let's take a look at the difference between var versus let. Now the main difference is with how the variables are scoped. However, there is another difference as well, and it has to do with hoisting. So first, the scope of variables declared with var is the function itself, or if they're declared as a global variable, it is the global environment. Whereas variables that are declared with let, the scope of those variables is simply the code block the block of code contained within curly braces. Now, as for hoisting, variables declared with let appear not to be hoisted. Now, from an application perspective, that is true. So the way we use it, that seems to be true. But in reality, they are hoisted, just not initialized. We will discuss hoisting in the next topic. So in this movie, we'll just deal with the example of scope. In this example, I have a function that is logging to the console, but it's going through a for loop, and it's logging the value of I to the console each time we go through the for loop. Once the for loop is complete, it then logs I one more time. Now, in this first example, we declare I with var. Let's go ahead and call that function and see what happens. Refresh, console. 1, 2, 3, 4, and then 5. This is the final console statement here because the for loop was as long as it was less than 5. All right, now let's change this to let. Now remember, let should define the scope of the variable to the code block. There's our code block. So let's see what happens when we try to log I to the console at line 15. Save this. Refresh. We get the first 4 just fine, but once we get to that final console.log statement, we get a reference error where I is not defined. And that's because I was defined with let. So the scope is limited. So that is the difference in scope between var and let. Now, you may be asking yourself, well, how does const figure into this? Well, const is just like let when it comes to scope. So the scope that it defines is that block scope. All right, let's move on to the next topic. The next concept we're going to deal with is hoisting. This is a concept that sometimes gets ignored because it may be considered basic, but it is still relevant. So let's talk about hoisting. So to hoist means to lift or raise. And hoisting in JavaScript refers to variables and function declarations that are lift or raised to the top of your code. Now, that is a definition that helps illustrate the effects of hoisting. However, it makes it sound like the JavaScript engine is moving your code. That is not happening. Here's a more technical definition for reference. So, during the compile phase, which takes place right before your code is executed, the code is scanned for function and variable declarations, which are then added to the memory. This allows them to be used even before they are actually declared in the source code. So what does all this mean practically? Well, this simply means that you can reference them before they are declared. Because they are raised to the top, the JavaScript engine knows they exist, will not give you an error when you try to reference those variables, or in the case of a function declaration, it will be able to find that function and invoke it. So that's basically what hoisting is. But let's take a look at some examples to illustrate it better. So let me jump to Sublime. All right, here I have a simple function. Hoisting is what I've called this function. It has 3 console log statements. The first one logs to the console hoist. Notice where hoist is declared and a value is assigned to it. Clear down here. We then declare a variable what and assign the value of this statement, variable and function declarations, and then we log to the console what is hoisted and that variable. Then the very last console log statement, hoist means and the hoist variable, which is defined here. So let's invoke this function and see what happens with these variables. One other thing I'm going to do is I'm going to invoke that function from up here. So I will invoke it before it has been defined. So let me go ahead and save that, and let's see what happens. Refresh, open the console. All right, so first thing we should notice is that the function did invoke, it did execute. Even though we called it up here and it was declared at line 3, it still executed. So function declarations are hoisted to the top so that we can define them anywhere in our code, and they're available for us throughout that same scope. We don't have to declare the function first and then call it down here. Now, what happened with the variables? First, the console.log statement for hoist. Notice that it indicates undefined. Now, it did not give us an error. Normally, if a variable does not exist, we receive an error in JavaScript. For example, let me just comment this out. Save it, come back, refresh, and notice we get an error this time. Uncaught reference error, hoist is not defined. We receive that because nowhere within the scope of function hoisting is the variable hoist being declared. Therefore, we receive an error. But if it is declared, the JavaScript engine knows that it exists, and so no error is generated. However, the results are undefined because it knows the variable exists, but the variable does not have a value yet. That value is assigned down here at line 10. So it simply prints undefined. Now with these other log statements, we don't have any issues because it is accessing the variable after it's already been declared and a value's been assigned to it. So the variable hoist was hoisted to the top, meaning all the code inside this scope knew that it existed. It didn't have a value until line 10, till the JavaScript engine had processed to line 10, but this statement knew that it existed, so it did not generate an error. For the function declaration, the JavaScript engine knows it exists and that it is a function, and so when we invoke it, it finds it and executes the code within. All right, let me delete this and add another example. This time I'm going to create a function expression, not a function declaration, because I want to show you the difference. This function is simply going to log to the console the sum of two numbers. And those numbers are declared down here. We'll check out that hoisting of variables again. Now the other thing I'm going to do, I'm going to try to call that function up here. Just like we did with the function declaration. This time it's a function expression, and we'll try to call it before it is defined. All right, let me save that, jump out, refresh. We get an error. Sum is not a function. So the JavaScript engine knows that sum exists. For example, if we were not trying to invoke it, we wouldn't get the error. So it knows that it exists, but it does not know it's a function because a value has not been assigned to that variable yet. And the value that gets assigned is a function. And so it's trying to execute something that it says right now it's not a function. I don't know that it's not a function, so it generates an error. So with the function expression, the call must be after the function is declared. Not true with the function declaration. Now, when we try to add those numbers together, we get NEN. because right now it sees these as undefined and tries to add them together. Does not give us an error because it knows they exist, but since they are undefined, it's not able to add them together. So we place it up there, and we get the correct number. I should mention, in case there's some wondering or some confusion, an arrow function is a function expression, so the same thing applies. Now, so far we've been using var for our declarations, but what happens if we use const or let? Let's take a look at that. I've commented out the previous code, and now let me add a log statement for a variable declared with let. Let's go ahead and do that down here. So first we'll put the console log statement in, and then right below it we'll declare it. Let's see what happens. We get an uncaught reference error, cannot access none before initialization. So our let and const variables not hoisted? Well, that statement is not exactly true. All declarations, function, var, let, const, and class are hoisted. However, the var declarations are initialized with undefined. But let and const and class declarations remain uninitialized. And so that's why we get the error that we're seeing here, because it is not initialized. Let's make a change and look at that same code again. So I'm going to come up here and just declare the variable, and then down here we'll add the value to it. Save that, and let's do this again. Now you can see that we get an undefined, similar to what we would get if we had done that with var. And so in that case, it's undefined. So after all of this, what do we gain? What do we learn? Well, first thing I want to recommend is that you don't rely on hoisting. Realize that it is there and understand it to avoid bugs, but follow practices that will help avoid relying on hoisting. So let's look at what some of those may be. So first, declare variables at the top of their respective scope. So if it's in a global space, at the top of that, or at the top of a function, at the top of a module, that's where you should declare your variables. Also, always try to initialize your variables when you declare them. Give them a value. That's a good practice as well. And then this third item, this is one that I follow. It may not be recommended by other JavaScript developers, but I like it because it helps make my code much cleaner. And I use function expressions instead of function declarations almost always. So for example, instead of doing this, I would do this. So this is a function expression, and this is function declaration. This is not hoisted, as we have seen, and this forces you to declare the functions before they are used, and I think that makes cleaner code. So those are a few rules to follow when you take into account hoisting in JavaScript. All right, let's move on. How would you respond if I said JavaScript is the most object-oriented language out there? Some might immediately reject this idea and begin naming all the different ways that JavaScript does not follow the traditional object-oriented programming paradigm. And that is true. It doesn't follow the traditional OOP paradigm. But what I mean by that statement is that JavaScript makes greater use of objects than other languages. Objects are everywhere in JavaScript. In many OOP languages, you must create a class before you can have objects. In JavaScript, objects are available from the get-go. So let's break that down by looking at the different data types that are available in JavaScript. Here are JavaScript's data types. Now, the first 7 data types are considered primitives. These are immutable, meaning they cannot be changed. Where data type number 8, an object, that makes up the rest of what we work with in JavaScript. So you can see there are multiple things missing from this list. Functions, arrays being probably the most common. Well, those are objects. They're included in the object data type. So string, number, boolean, undefined null, symbol, big int, those are all primitive data types. Values cannot be changed. Now, big int is the newest data type that has been added to JavaScript. Where the others listed there, if you've been around JavaScript for any time, you're probably pretty familiar with. Now, an object in JavaScript is a composite value, meaning it combines multiple values into a single entity using key value pairs. Another important point about objects is that they're mutable. They can be changed, as I mentioned. So let me jump over to Sublime. We're going to look at some common things we work with in JavaScript that are objects. So here are several things I've set up that are objects. We have a function first. We have an array. Here is a user-defined object. We have a date. We have a set. We have a map. These are all available in JavaScript, things we can work with, but they're all objects. Now, because they're all objects, they have the attributes of objects, and that's what I want to show really quick. So if I open up the console, and the one function that we did define was test fun. If I do a console.dir on test fun, let's see what we can look at. We can open up that function and we can see that it has properties and methods. For example, the length property of functions, that indicates how many arguments have been passed in to that function. And as with all objects in JavaScript, it is associated with a prototype. And inside of that, we have additional methods which we can call on. Now, prototypal inheritance is another concept that we will talk about, and it's a very important concept in JavaScript. So we won't go into that in detail here. But let's take a look at what we can do with this function since it is an object. I can add a property to it, my own property. And that property can have a primitive data type associated with it, or it can have another type of object. So now I have a property added to this function that I can display. So basically, this is when this function was created, because I used a date object and associated it with a function object. Now we also had an array out there. Let's take a look at that really quick. We can see how the array is set up as an object. It has a property. It has a prototype with a bunch of methods that we can access. And once again, we can add our own properties to an array object. I'll just give it a name property and set it to a string, my array. So we can see from that really quick demonstration that these are all objects. A lot of the things we work with commonly in JavaScript are objects. And that's why I make that statement that JavaScript is the most object-oriented language, because we are constantly working with objects. Now, another thing to be aware of is even the primitive data types that I mentioned, many of them have what is called an object wrapper. And that gives them some features that are attributable to objects. Let me give you an example. Let's set up a string here. So here we have our string. Now, what's available with a string? What can we do with a string? Well, the string object wrapper has methods associated with it and properties. For example, we can do str.length. That's a property associated with a string, and it returns the number of characters in that string. As you can see, there are also a number of methods available with a string. I'm going to use the split method. And we'll create an array from that string. And here we have an array with 2 elements in it because I split on the space. And so it split between the 2 words, created an array. So one of the methods that's available on strings. So these primitive data types even have what we call string object wrappers, which allow us to work with these primitives like objects. So the main takeaway is that objects are everywhere, and the influence of objects are everywhere within JavaScript. And that is such an important concept to remember when working with JavaScript. And because objects are everywhere in JavaScript, it's very common for us to work with things using dot syntax. I specify the object or the string object wrapper like I've done in this case. I use a period, and then I access the property or the method, as we've seen here. And that's available for all objects and object wrappers in JavaScript. And so many of the things that we work with in JavaScript have methods or have properties that allow us to do more. And those methods, properties, may be inherited from the prototype, but either way, they're available for the objects that we're working with. Whether it be a user-defined object which we created, an array, a function, or a primitive that's wrapped in an object. Those things are available for us, and therefore makes this concept important to understand. All right, let's move on. The fourth important feature of JavaScript that we're going to deal with is prototypal inheritance. I'm going to divide this into 2 topics. We'll first talk about what the prototype is, and then we will look at how you can set the prototype. So first, let's deal with what the prototype is. Almost every JavaScript object has an internal property which is a reference to another object. That object is referred to as the prototype. Let's spend a few minutes examining the prototype in order to understand it better. First, I want to cover some concepts about the prototype, and then we will look at some examples. So first off, as mentioned, almost every object is linked to another object. That linked object is called the prototype. Now, the reason we say almost is because the default object in JavaScript does not have a prototype, and it is possible to create an object with a null prototype, meaning it is not linked to another object. Now, objects inherit properties and methods from its prototype ancestry. Now, the word inherit here means that that object has access to those properties and methods. It can use them. They don't belong on the object. They are not a part of the object. They are part of the object's prototype, but the object has access to them. And the reason we use the term prototype ancestry is because an object has a prototype, but that prototype object can also have a prototype, and so on, up what we call the prototype chain. So the object can use any properties and methods that are on that prototype chain that belong to any of the objects that are a part of that prototype chain. So that's why we use prototype ancestry. Now, a prototype is automatically assigned to any object when it's created. Now remember, other than the primitive types in JavaScript, everything is an object. So we're talking about arrays, we're talking about functions, we're of course talking about JavaScript objects. And finally, you can define an object's prototype. That's where the power prototype comes in, is when you're able to define what that prototype is. Our next tutorial will cover methods that can be used to define an object's prototype. All right, let's take a look at a diagram that can help illustrate the prototype. So here on the left side, we have an object. Its identifier is user1. It has some properties, username, and the value is John, age 32, address, city. Full address is a function, and there's code inside of that function. There is a default property assigned to this object, and that default property is referred to using both of these terms. That is basically a link to another object. And so if we follow the link, we have another object that can have properties and methods assigned to it as well. It can have a link to another object, a prototype as well. So this is the prototype chain. And you can continue out the prototype chain until you get to the topmost object. Now, if in our code we were to refer to user1.state, what would happen is the JavaScript engine would first look on this object, the object we've defined. It would look for a property of state. If it can't find it, it would then follow the prototype link to the next object that is linked and look for a property of state there. If it finds it there, it returns it. If it doesn't find it, it continues up the prototype chain. If it gets to the uppermost object in the prototype chain and is not able to find the property that is referred to, then it returns undefined. Okay, let me open up the console and let's take a look at some examples that I think will help cement these concepts. So first off, I'm going to create a simple object using object literal notation. Now I have my object. There's nothing in it. I didn't put any properties or methods as a part of that object. However, I can do this. I can access a toString method of the object, and when I press return, it displays information to the console. So why am I able to access that method when I did not create it? Well, it's because it's a part of the object's prototype, the default prototype that's assigned when the object is created. So let's take a look at that object so we can see that. Here is the object. If I open it up, there's nothing inside the object. However, there is a link to the prototype, as we can see here. If I open up that, we can then see there's a number of methods that are associated with the default object that is assigned as the prototype. One of those is toString. That is why I'm able to enter obj.toString, because it exists on the prototype, and that's where it accesses it. So when I entered that, JavaScript went up the prototype chain until it found a method toString, and then it invoked it. All right, now what happens if I define on obj my own toString method? I'm just going to have it logged to the console object, and that's all. Press return. I've now defined a function on the obj object. Now if I enter obj.toString, you've probably guessed, it will find the one that is on the object and execute that. So it doesn't execute the one that is on the prototype. Now if we look at obj one more time, open it up. Now we have something in our object, but we still have a link to the prototype object. However, when toString is entered, it finds this one first, and so it executes that function. All right, one more example. Let's create an array. Now, as mentioned, anything but primitive data types are objects in JavaScript. So an array is an object. Now, how are we able to do this? We can do the index of on an array and find the location of that in the array. But why is the index of method available? Well, it's because it's a part of the array prototype. So let me open that up. Here's our array. If I open that up, we can see the values, and we have a link to the prototype right here. If I open that up, we can see that there's a number of methods and properties that are associated with it. One of those is index of. And so that's how we're able to execute index of. Now notice as we continue, the prototype of the array also has a prototype. Inside that, we see a toString method. Well, let's try something. If I do array.toString, well, that's different than the toString method for the object we created. Why is it different? Well, once again, looking at the array, the prototype of the array, if you'll notice, has a toString method as well. Yes, there is a toString method on the prototype of the prototype, but it's executing this toString method, which is created specifically for arrays, and therefore it functions differently than the toString method that is used for a JavaScript object. So that's prototypes. In the next topic, we're going to look at how we can assign a prototype to an object. So let's move on. With an understanding of prototypes, you are now ready to learn how to set the prototype of an object. This sets the object up to inherit or have access to the methods and properties on that prototype using prototypal inheritance. Now, the prototype can be key to structuring your code efficiently. Although it is different than classical inheritance, prototypal inheritance is very powerful. A good rule of thumb is to place reusable pieces in the prototype object. In order to make use of the prototype, you need to know how to set the prototype of an object. And in this tutorial, we will look at 3 ways to do that very thing. And we'll use some very simple examples to illustrate that. So let's first take a look at what those 3 ways are. First off, we can use a constructor function. So that is one technique, and that is probably the most common technique. Second, you can use object.create. With object.create, you're creating a new object. And as a part of calling the create method, you pass in an object that will be set as the prototype of this new object that's being created. So object.create is a second method. And I like that method because it's very straightforward. Third, as of ECMAScript 6, that standard defined a setPrototypeOf method, which is a part of the object. Now, a setPrototypeOf, you're able to establish the prototype of an object that's already been created. Just one precaution with setPrototypeOf, you should probably avoid it if you can. There are warnings that it is resource intensive to use this particular method. But I'll show you how to use it in case you choose to use it. Now, there are other techniques that set the prototype in JavaScript. But I've chosen to focus on these three because they are the most straightforward, and they will allow you to accomplish what you need when you're trying to set the prototype of an object. So let me jump to Sublime and we'll take a look at these examples. Now, the first thing I want to do is I want to set up an object that I'll use as the prototype. So as you know, the object you create, its prototype links it to another object, and it can then borrow properties and methods from that object that it is linked to. So I'm going to set up a simple object. And I'll do that using object literal notation. And in this, I'm simply going to place a function. And we'll create three different objects, and this function will be used by all three of those objects. All it's going to do is log to the console a greeting, similar to hello world. All right, there is our object that we have created, and we'll use this object as our prototype. So let's take a look at the first method I mentioned, which is using a constructor. So let me set up my constructor function. I use an uppercase G to indicate that it is a constructor. We're going to have a term passed in. And then we will set the object that the constructor is creating, we'll set the greeting property of that object to the term. Now we have our constructor function set up. This will allow us to create a new object with the keyword new. You have to use the keyword new with the constructor function in order for that to happen. However, we have not established the prototype. Functions have a prototype property, and we can establish the prototype for all objects that are created from a constructor function by setting that prototype property to an object. So let's do that. Greeting.prototype equals obj proto. We'll set it to the object that we've created. Now we have all of that set up, we can create our object. And to create it, we call the constructor function using the keyword new. And we're going to pass in a term. All right, we have our object created. Now let's take a look at that one before we look at the other two methods. Let me save that. I'm going to refresh this and open up the console. And obj1 dot greet should display to the console howdy world in this case. Now let's take a look at obj1. Let's just display it. There we can see the greeting property is set for the object. And here we can see a link to the prototype. If we open up the prototype object, we can see that the greet function is a part of the prototype. All right, so that's method number one. Now, the second method is using object.create. I prefer the constructor function when you're creating numerous objects of a similar type. Well, the thing I prefer about object.create is it's so straightforward in establishing the prototype and the object you're creating. So here's how we do that. We're creating object, or obj2 this time, and we'll set that equal to object.create, and we're going to pass in the prototype object. Now, once that object is created, obj2, I can add other properties and methods to that if I want to, using .syntax. So there I've added a greeting property to it. Now we have object2 created. Now it is possible we could also create additional properties onto the object by passing in a second object here that defines the name value pairs. So as a part of object.create, we could pass in a second object that defines the name value pairs. Okay, let's save this and take a look at this object. I'm going to refresh the page again. This time we'll take a look at obj2. Greet comes back with hi world. If we open obj2 and take a look at it in the console, we can see it has a greeting property established to it. It also has a link to a prototype object, and inside that prototype object we see the greet function. All right, the final method, set prototype of. This is something that became available with ES6. But let's go ahead and look at how this one would work. So first let me create an object, obj3, and I'm going to create that using object literal notation. Set the greeting property to hello. Now we have an object we've created. We can then set its prototype. By default, when that object's created, it has a prototype set for it, which is the default object in JavaScript. We can override that using set prototype of and pass in the object itself, obj3, and then pass in the object that will be used as the prototype. All right, I'll save that, jump out, refresh again, misspelled set prototype, save it, jump out, still misspelled it. There we go. Now let's go ahead and take a look at obj3, greet. That one says hello world. If we look at obj3, we'll see similar to what we've seen with the other objects. We have a greeting property. We're linked to a prototype object. We open that, we can see the greet function in there. All right, so those are three methods for setting the prototype of an object. Let's move on to the next topic. The next important feature of JavaScript that I want to discuss is higher order functions. Now, before we jump into discussing higher order functions, let me first address the fact that functions in JavaScript are first class. Now, this simply means that functions are treated as values. So we can assign them to a variable. We've seen that. We can pass the function around because it is treated as a value. So how does this concept of first class relate to the concept of higher order functions? And why are the concepts necessary? Well, let's first take a look at a definition of higher order functions. So higher order functions are functions that operate on other functions by either taking them as arguments or returning them using the return statement. So the fact that JavaScript supports first class functions makes it possible to create higher order functions. So the concept of first class functions explained how functions are treated in JavaScript. The concept of higher order functions explains how we use them. The reason we use both of these concepts to discuss functions in JavaScript is it helps us to understand what is possible and therefore take advantage of the power of the JavaScript language. That is one of the huge strengths of JavaScript, the fact that functions are first class, and that because they are first class, we can create higher order functions. Higher order functions is a major concept in functional programming. Now, the most common application of higher order functions in JavaScript is the callback. There are several methods in JavaScript that allow us to pass a function that will be used as part of that method. Arrays are a great example. We'll use the sort method of arrays to illustrate that. So let me jump to Sublime and we'll look at a simple example. Here we have an array. It contains things: building, car, bicycle, automobile, tree, house. And then we are doing a sort on that array. Now, looking at the items in that array, will this sort correctly? Well, let's go ahead and find out. Let me open the console, and I'll just display the things array. Sort actually does not create a new array when it sorts them. It sorts the array it acts on, and so it modifies that array as opposed to producing a new array. So if we look at the things array, we will see it sorted. However, notice how the sort is taking place. Uppercase letters, the B and the T are uppercase, are coming before lowercase letters. So it's not really in alphabetical order. So we're going to use the sort method to do a case-insensitive sort. And this particular application, though a little bit different, I have taken from David Flanagan's book, JavaScript, the Definitive Guide. Now, in sort, you can pass in an argument. And the argument which you pass in is a function. Therefore, sort is a higher order function. It has been built to perform its operation with a function that we can pass in. So we could pass in a function here. And the function we pass in needs to be able to receive two values. And then it compares those values. So it's a comparison function. And it receives those two values as arguments and determines which should appear first. Now, the way it does this, the way it determines which should appear first, is if the function returns a negative number, the first argument will appear before the second. If the function returns a positive number, the second argument will appear first. If the function returns a 0, it means the two arguments are equal. So it doesn't matter which appears first. So the function we pass in needs to return a negative number, a positive number, or a 0. So one of three values. And then sort will use that to determine the order it places the items of the array in. So let's begin writing this new function. So obviously we're going to have act on things, and we're going to use sort. Now we're passing in a function, and we will pass in an anonymous function. It has two arguments. It will receive two arguments from the array at a time, and then it must return a positive number, negative number, or 0 so that sort can determine which order to put the items from the array in. So let's look at how we'd create this. First, we're going to declare a couple of variables, and we'll just convert the arguments to lowercase. All right, so we have converted the arguments to lowercase, so we'll now use x and y to determine which should come first. So if x is less than y, we will return a -1. Remember, a negative number will indicate that the first argument should come before the second argument. Do another if statement. If y is less than x, we'll return a positive number. And finally, if none of those are the case, we'll return a 0, meaning they are equal to one another. So we have just used the concept of higher order functions. We were able to pass in a function, and the sort method will use that function in its computations. So it will use it to determine the sort order. So the concept of higher order functions was used to make this possible. Now let's save this and see how our sort works. Refresh, and then I'm going to display things again, and notice our sort is correct now. Automobile, bicycle, building, car, house, and tree. So applying the concept of higher order functions using the sort method. And we see higher order functions everywhere in JavaScript. In the next topic, we're going to dive into callbacks. And without higher order functions, callbacks would not be possible. Let's move on. The next feature of JavaScript we're going to dive into is callbacks, a super important pattern to talk about. Now, callbacks are used throughout JavaScript. In fact, many native commands make use of callbacks. Add event listener, set timeout, map, reduce, filter, and many others. So if you aren't incorporating the callback pattern in your own code, you may want to look at doing that. Let's look at some code and see how we might use the callback pattern with it. Now, the purpose of this code was to act on an object and selectively pull out parts of that object and return it as another object. And this was the object we're using as a test case. So basically, it's got first name, last name, and then it has a bunch of scores. And these scores are ordered by section and quiz number. And the key represents that. So S1, Q1 is section 1, quiz 1. And you can see the rest of the keys as they are there. Now the code, it would selectively choose parts of an object and then return that. So right here, we pass in the object, and then we indicate which section we want to retrieve. By default, it will do section 1. And then using a for in loop, it goes through that object and creates a second object by copying the key and the value into the new object based upon whether it's of the right section or not, which is what we check right here. So this function is very useful for pulling out parts of those objects and allowing me to work with particular sections of scores. Now, what might make it even more useful is if I could, at the same time I'm pulling these out, work with that data. So for example, maybe I want to do something with the scores as I pull them out and put them into a new object. Well, using the callback pattern, we could do that. Now, functions in JavaScript are first class, and therefore they can be assigned to a variable and passed around. So with the callback pattern, what we do is we pass a function into another function. So this here would contain a function, and we can do that because functions are first class in JavaScript. And then we use that function to process some of the data. In this case, we would use it to process the value before we set it up into a new object. And I can choose how I process that by the function that I pass in. Therefore, it provides a lot of flexibility. So let's look at how we might take advantage of the callback pattern with this pull scores function to make it even more versatile. So here I've added a parameter so that I can pass in a callback if I would like to. Now let me just change some things inside this if statement so that we can actually use that callback. The first thing I'm going to do is set the value into a variable. Now I want to do that because then I can act on that value if I need to. Right here, I'll just change this to the variable that I assigned the value to. Now in between these two lines, this is where we would check the callback, make sure it's a function. We don't want to invoke the callback function unless it really is a function. And so we check that, and then we invoke it, pass in the value, it returns its results, and then those results get placed here instead of the original value. Okay, so let's look at how we do that. So a simple if statement, and we use type of to check that the callback is a function. And this is an important step in a callback pattern. You want to make sure that before you invoke that function that has been passed in, that you verify that it is a function. And that's what we've done there. Now we can simply set this up like this. We invoke the function here, and we pass in the value. And whatever it does to that value, it returns it to our variable again, and that variable gets assigned to the key in the new object we're creating. So there we have it set up. Now all we need to do is test it out. Let's save this, and let's first test, make sure it's working even if we don't pass in a callback function. So console, we'll just take a look at that new OBJ that it returns. And we can see that it is still grabbing section 1 of the quizzes into this new object. Just to verify that, here are all of the section 1, and it grabbed those and put those in, even the null value. And so that's still working even if we don't pass in a callback. But now we want to see the flexibility of this. Let's go ahead and pass in a callback. Let's say that we wanted to take any null values and set them to 0. So if the quiz hasn't been taken, if no value is there, then we are going to say that it's just 0. So we can pass in a function. We can do that with an anonymous function. We want to make sure we give it a parameter to accept the value that is passed in. And then we set up our function with what it's going to do. And there's a couple of ways we could do this where we could replace the null value with a 0, but we'll just use a traditional if statement. We'll just check to see if it's equal to null. If it is, then we return 0. Now, if it's not equal to null, we want to make sure we return the original value. So we need to add an else. We do it like that. So now this function, put some returns there, this function is being passed in to the callback variable. Then the callback variable is checked to see if it is a function. If it is, then it invokes it, passes in the value that we retrieved right here, passes in that value, the function processes it, returns it to the variable, that a variable gets assigned to the new object. So that should replace any null values with a 0. And the original value should just be returned. I noticed I added an extra L there. So the original value should be returned if it is not a null. Okay, let's save that and see what we get. Refresh. Let's go with new object again. And now we can see that the value is 0. Now, what if we wanted to do something even more? What if we wanted to return the score for all of these based on 0 to 100? So, for example, this one would come back as 90 because it's 9 out of 10, 5 out of 8. This would still be 0 because there would be no score for it. This one here would be 20. So based on 100, what would the score be? Well, here's how we could do that. We still return 0 if it's a null value, but if it isn't, Then we can process it a little more. And so what I'm going to do here is run split on the value, and we're going to split on the colon. What that's going to do is give us two values in an array, two separate elements in an array. 0 will be this, position 1 will be that. And then we can easily figure out what the score is. And we will return that score. We're going to do that by dividing the first element by the second element. And that's going to give us a decimal value, 5 divided by 8. And then if we multiply that by 100, that will represent a score between 0 and 100. So we can work with it like that. So let's go ahead and check this one out. Save that. Let's take a look at new object again. And there we have the different scores. We can see that we still get the 0, get the 90 here, 20 as we looked at before. So that's allowing us to process it even more. So the callback pattern. There's some important advantages to the callback pattern. One is you don't repeat code. It helps you not to repeat code. So we use the same function, but we pass in different functions to process the value instead of redoing things for each one of those. We simply send in a new function when we want to do something different. So it helps prevent repeating of code. And now this is a higher order function because it accepts a function and uses it as a part of what it's doing. It also makes your functions more generic and versatile so that you can handle a lot of different functionalities. We've been able to see we handle 2 different things here. And it can make your code more maintainable. This main function that we use over and over, we only have to deal with the code in one place, so it is more maintainable. So those are some of the advantages that we get from the callback pattern. All right, time to move on to the next topic. Immediately invoked function expressions, or IFEs, are a common pattern in JavaScript. However, for the uninitiated, they may seem a bit confusing. Well, we're going to address that in this topic. IFEs are a staple of JavaScript development, so let's make sure you understand them. First, let's talk about the name. The name for this construct tells you exactly what it does. This is a function expression which is invoked immediately. Therefore, immediately invoked function expression. In fact, the function expression is invoked at the time it is defined. Now, when would you use IFEs? Well, here's a scenario. Your code needs to do some setup tasks when the page loads, such as setting up event listeners. You only need to do this once, so there is no reason to create a reusable function. And by doing it with an IFE, you prevent the creation of global variables because it provides a local scope for all of your code that needs to be invoked immediately. So that is one example of why you would need to do it. There are a lot of different patterns in JavaScript that use IFEs. Now, to understand how IFEs work, we need to look at an example. So now let's first set up a very simple function expression. I am simply going to multiply 2 numbers together. And I'll log the results to the console. So 5 times 5, that's all we are doing. This is our function expression. Now, how do we invoke this? Well, as you know, we use parentheses to invoke a function. So the parentheses at the end of this variable name will cause it to invoke the contents of that variable, which happens to be a function. Let's go ahead and save that. Let me refresh. Open the console. Of course, we get a 25. But let's also take a look at that variable. Notice what the variable contains. It contains what we defined in the function. So that's why when we enter the variable and then enter parentheses to invoke, it causes that function to invoke. Now, what if we wanted to invoke it immediately? What if we didn't want to include this line here? We simply wanted to put parentheses right there after we had defined it. Let's see how that works. Save that. And this time I refresh, I still get the 25. So it is still working. Let's take a look at the variable now. Notice the variable is undefined. That variable is no longer necessary because we are invoking the function immediately right here. There's no need to place it inside a variable. So that variable is unnecessary. Well, can we get rid of that part then? If I remove this and I save it, what happens? We get an error, unexpected syntax error. Unexpected token, and it's a left paren. So what is that error referring to? So if we jump back here, it's talking about this left paren. Now why would that be a problem? Well, because when the JavaScript engine encounters the function keyword, it assumes we are creating a function declaration. And so the next thing that it should see is a name for that function, not a paren. So when the paren is there, it gives us a syntax error. Well, in JavaScript, we can enclose anything inside of parentheses. And by enclosing this inside of parentheses, it will keep it from being a syntax error. Because the first thing it sees is a paren. It's not going to assume that we are doing a function declaration. So if I enclose the entire thing in parentheses and then save it, refresh, there we have an immediately invoked function expression without the variable declaration, which is what we want. So this function expression is now being invoked immediately at the time we define the function. It creates a local scope for any of the code that's inside the function so that we avoid creating global variables. All right, let's look at this one more time. I'm going to remove these parentheses and walk through this one more time. So here we have a function expression. Now, as we know, this will generate a syntax error because we have function as the first keyword. So if we enclose it in parentheses, that now becomes valid. If we save that and refresh, we don't get a syntax error. But we also don't get the results appearing on the console either. And that's because we did not invoke it. Well, now we can add parentheses to invoke it. And there we go. So this is a second way to create an immediately invoked function expression. We enclose the function expression in parentheses first, and then we put the parentheses to cause it to invoke. So both methods work fine. Some people prefer this. This is actually the structure I prefer. I think it's more intuitive. We're enclosing it in parentheses and then we're invoking it. Other people prefer that structure there. Both work. So you can really choose whichever one you want to do. Now, what if you chose to use an arrow function when you're creating an immediately invoked function expression? What would that look like? Well, let me create the same function, but this time we'll use an arrow function. Fat arrow console.log. Have it produce the same thing. So there's our arrow function. We can now enclose that in parentheses and then invoke it like that. So that's how it would look as an arrow function. I actually prefer the traditional method. I don't know if that's because I'm used to it or not, but I feel it communicates better that this is an immediately invoked function expression so that we can see immediately, oh, I know what this is. I know what this is going to do. I just feel it communicates better. That's why I prefer that. But this is how it would look with an arrow function. So that is immediately invoked function expressions. That is how it works and why it works in JavaScript. All right, let's move on and talk about a super important concept in JavaScript, closure. The next concept I want to tackle is closure. This may be one of my favorite features of JavaScript, and it is definitely critical to understand. Closure is sometimes seen as one of those mysteries of JavaScript. I still remember when I first grasped the idea of closure. It was an aha moment for me. And since being able to grasp that, I've been able to see how much it is used within JavaScript, and also I've been able to apply it to solve certain problems. So closure is not a new construct. It's simply a concept that's used to describe what's possible within JavaScript. And by understanding it, it opens up possibilities for you that you may not have thought of in the past. And it enables you to understand JavaScript code that is frequently being written out there. So let's take a few moments and demystify the whole idea of closure. Now, closure is closely related to scope. So I want to define scope briefly as a starting point. JavaScript uses function scope, meaning functions determine the scope of items that are declared within that function. And scope basically refers to the rules that determine where within our program, the program we write, variables and functions are accessible. Now let's define closure. I've gathered 3 definitions of closure that we'll look at first, and then we'll look at several examples. First off, this comes from javascriptkit.com. A closure is the local variables for a function kept alive after the function has returned. So what it's saying is when a function is finished, those variables are still accessible. Another definition. Closure is when a function is able to remember and access its lexical scope, even when that function is executing outside its lexical scope. Now that definition comes from Kyle Simpson. He wrote the book Scope and Closure, which is a great book for defining both of the and understanding both of those terms. And third, a closure is a function having access to the parent scope even after the parent function has closed. That's from W3C Schools. So in these definitions, it talks about code executing outside of a scope and yet still having access to that scope. That's the commonality of those definitions of closure. So let's jump to some code and begin looking at some examples. Now, in this code, func2 is inside of the function funct. It is part of the scope of funct, whereas we see the function funct3 is completely outside of that scope. Func2 does have access to the scope, but it's executing inside that scope because it's called as the very last thing, so it executes before this function has completely finished. So it illustrates scope, but perhaps not closure if we were to get really technical about it. So let's make a change that will show closure. And a great way to do that is with callbacks. Callbacks are definitely functions that execute outside of the scope. So I'm going to enter set timeout, and I want it to execute func2 after 1 second. Now, if you're not familiar with set timeout, this is a function that allows you to call and execute code after a certain length of time. It takes two parameters. The first is the code that will execute. Usually that is entered as a function, normally as an anonymous function. In this case, we are just calling a function. And the second parameter is the number of milliseconds that should wait before it calls that code. In this case, 1000 milliseconds, 1 second. So when we call this, it will set up the scope, it will set up this function, and then it will call set timeout. And at the time, right after it calls set timeout, this function is done, it closes, it's no longer running. However, a second later, it then calls a function that was part of it. And that function right here then has access to these variables because it retains that access to the scope, even though it's executing outside of that scope. So let's save that. Open the console, and we'll go ahead and refresh and execute it. And 5 appears. So we get a pause of a second, and then 5 appears. So that first function is already closed. It's done. It's executed. But we then, through the set timeout command, call back to that function that was defined inside that scope. And it still has access to its parent scope, and it can add those numbers together. So one example of closure. So the way we would describe this is func2 closes over the scope of funct and continues to have access to it. That's where the term closure comes from. All right. Another example. I'm going to go to a different page where I've got 2 buttons created. I'm going to use this as an example. This will also use callbacks, but we'll use this with an event handler. I'm going to paste in some new code. So here we've declared a function counter. Inside of that, we've declared a variable CNT, which we're going to use for simply counting. And then we have accessed the 2 buttons which are on the page. They have an ID of item 1 and item 2, and so we've grabbed those so that we can add an event listener to them. We've then declared a print function, and that simply logs the value of this variable to the console. That's all it does. To each one of those buttons, we've added an event listener, and the function for the code they will execute is count1 for the first one, and that simply increments the CNT variable and then calls the print function. And then count2 for the second one, it does the exact same thing. Now when we call this function, it will execute and it will complete and it will finish. However, when we click on the button, they will still, or buttons, they will still have access to this variable and to this function, even though that function has finished. Now one way to show this working would be simply call the counter function at this point. But what's commonly done when you have a function set up that you only want to execute once is simply to immediately invoke that. So the way I would do that is put parentheses after the function definition. Now since we're going to immediately invoke that, I'd remove assigning it to a variable. I'll put parentheses around it. We now have an immediately invoked function expression. But the real concept that we want to convey here is closure. That even though this function immediately invokes and finishes function count1 and function count2 will still have access to the scope that was created by function counter. So it will have access to that, and it will have access to the print function as well. So let's take a look at that. Save that. Refresh. Click on one button, and as we can see, it increments and prints out a 1. Click on it again, increments it again, prints out a 2. So it keeps, that variable is keeping track of the value. Even if I click on a second button, which executes an entirely different function, it still retains that value and increments it by 1, because they both have access to the same scope. So jumping back and looking at that code again. So one way to describe this is that count1 has closure over the scope of counter. We could say that about count2 as well. Or another way to say it is count2 still retains a reference to the scope of counter, and we call that closure. All right, one additional JavaScript pattern that illustrates closure very well is the module pattern. Now, that very pattern is what I plan to discuss in the next topic. So let's go ahead and move on. The module pattern is one of the most important patterns in JavaScript. In dealing with modules, I'm going to be talking about the traditional module pattern that has been used for years in JavaScript. Now, I'm not going to talk about modules that became a part of vanilla JavaScript with ECMAScript 6. That is a topic for another day. We are going to look at the module pattern that has been part of JavaScript for years. You will surely encounter it at some point. The purpose of this pattern is to create self-contained code that avoids collisions. Let's first look at the advantages of a module. So first off, I mentioned a module avoids collisions. This is referred to as namespacing. Now in JavaScript, global variables are available all over and can be written by other code or for people working on the same project. And so the idea of avoiding collisions is avoiding the creation of variables that could collide with a variable of the same name that someone else has created in that same space. So creating a module helps to avoid those problems so that we can use any variable we want in our code, and we don't have to worry about whether that variable is unique enough or not. Now, the second advantage is reusability. Well-written modules are easier to reuse. You can take that module, that piece of code, and you can plug it in. Because a well-written module is self-contained, you don't have to make adjustments for the code you're putting it in or make adjustments to the module itself. And then finally, maintainability. A module is also easier to maintain. And that's because, as mentioned, a module is decoupled from all the other code that may be a part of the project. So you can easily go update that. You don't have to worry about those updates affecting code somewhere else in the project. So first, we're going to take a look at some code that I've set up already so that you don't have to watch me type it in. I've created a function. Communication is what I've named this function. Inside of it, I've created two variables, a greet variable and a goodbye variable. So the idea is that this module is going to handle communication. And right now, all we're dealing with is greetings. So we have a greet and a goodbye variable. And then down here, we have a function that displays a greeting. It uses a string template to put the greeting together and display it to the console. We also have a function up here, and this function gets the greeting message. And basically what it's doing is it's getting the date for the purpose of getting the time. then it converts it to the local time string, and then we just check to see if it includes AM. And if it includes AM, we replace greet with good morning. Otherwise, we stick with hello. So if they're logging in the morning, we want to say good morning instead of hello. So basically, that's what we have here. Now, a module is a function, and that's because a function has its own scope. So anything we create inside this function, we don't have to worry about collisions. We don't have to worry about it interfering with code outside of that function. So because of that scope, a function is a fantastic structure for a module, a self-contained piece of code. Now, the other advantage of using a function for a module is closure. A function creates closure. And so anything in this function we will have access to, even when the function is done, is finished, is no longer executing. We still have access to these variables and these functions because of closure. And so those two concepts make the structure of a function perfect for setting up a module, which is a set of self-contained code. All right, now as this is, it's not very usable. So for example, let me go out to the console here, and then I can create a global variable, and I can invoke the communication function, and it will cause everything inside that function to be set up. However, I don't have access to it. I can't get to that stuff. There's no way I can use those. And let's say that I want to be able to use this function. These other things I'm going to keep private. These I want to keep inside the function, and those won't be used outside of this function. They're just for the purpose of this module, and so I'm keeping everything inside of there. But this greeting function I want to be able to use. I need to be able to access it. So from code that's outside of this module, I want to be able to call the greeting function and have it print to the console, hello so-and-so, welcome to the course. All right? That's just our simplified functionality for this. So how do I make this available outside of this function? Well, here's how we do that. We consider this is going to be a public function. And so to make it public, what we do is we return an object that contains this function. All right, let's look at that. So I would type return, and then here's my object. And then inside of the object, I set up anything that I want public. So I'm going to put a comment here. Public methods and properties. And so I want to make this public. And what name do I want to make it public with? I could use the same name, greeting, or I could use a different name. I'm going to use a different name. So I'm going to put greet user. That will be the public name to access this function. And so now I'm going to tie that to greeting, just like that. So this object is going to be returned. And so anything that I set up with this function will have access to this object, which will in turn give us access to this method. But we'll keep everything else private. All right? Let's save that and go ahead and see how that works. So I'm going to refresh this so we have our new code. Oops, I got an error message. Oh, put a semicolon there instead of a colon. There we go. Save that. Refresh again. All right, now I'm going to do the same statement. Now this com variable, which is on the global space, this will have access to the greet user function. So now I can do a dot greet user. I can then pass in the name of the user that I'm currently working with, and there we get the greeting sent. And I'm recording this about 10 minutes before noon, and so we're getting good morning instead of hello. And so we've made a self-contained module. Now, right now, this could be used for multiple global variables, com1, com2, and so on. But many times when the module pattern is used in JavaScript, it's used as a singleton. It's used only once. And so in order to facilitate that and make it easier to set up, we use an IFI, an immediately invoked function expression, to have it invoked immediately and set up immediately. So now I'm going to change this so that we use an IFI for that purpose. So with an immediately invoked function expression, I can get rid of the function name because I can use an anonymous function for this. And then I can set up my global variable that is going to contain any public methods or properties that I want to provide from this module. And so this becomes the access to the module. That's what this is, the access to the module. Now I set up my IFI. I got to surround the whole thing in parentheses. And then I need to invoke it. So these next set of parentheses invoke it. And what gets returned to this is this object right here, which then gives me access to the public parts of this module. And so this would only invoke once. Com would then be the API that would give me access to this module. See how that works? Let me go ahead and save that, and we'll take a look at this again. So now I can just access com anytime I need to do a communication. In this case, the only method I have right now in this module is greet user. And so that's the one I'm going to access. And that takes care of the greeting for me. So here we have a very simple module, very small. Most modules contain a lot more code than this. But this illustrates the idea of the module. And we've been able to create our code self-contained. Nothing in here is going to conflict with anything outside of this function. We avoid collisions. This is the only thing that is now on the global space that could collide, and there are ways to even prevent this from colliding. So we've been successful in creating this module. Let's move on to the next topic. Whenever you are dealing with objects, it is important to understand the keyword this. And since JavaScript is such an object-focused language, the keyword this becomes a crucial topic. The binding of this, what this represents, can sometimes be difficult to understand. The thing that makes it difficult to understand is this is determined at runtime. And depending upon what happens within the code, it can be something different. But simply ignoring it because it's difficult to understand won't get us anywhere. There are some concepts that can help us in understanding the keyword this. So let's first take a look at those concepts. Now, understanding this, or understanding what the value of this is in a particular situation, which can also be called this binding, what is bound to this, is based upon some established principles. So let's first describe what this is. This is established at runtime when a function is invoked. This is determined by how a function is invoked, not where the function is defined. So it really doesn't matter where in the code you've placed the function. That doesn't determine what the value of this becomes. How that function is invoked will determine that. And finally, this is a reference to an object. So the value that this becomes is always an object. That we can say up front. It will always be an object. What that object is determined how a function is invoked, not whether or not the function is associated with an object. Now, many times when a function is associated with an object, when it is an object method, the value of this is that object. But that's not always true, so I don't want to say that as a statement to cover what this becomes, what this is. Now, this is not, it will never be the function. Though it is established when the function is invoked, it is not the function. It is always an object. So remember that. Now, one more thing I want to say about this, and that is the binding of a value to this, which we can call this binding, can be implicit, meaning it is set by the JavaScript engine, or explicit, meaning it is set by you. Something you do in the code determines the value of this. Those are some principles we want to keep in mind as we view some examples. So let's look at some examples that will help us understand this binding in a couple of different scenarios that you may encounter. So let me jump to Sublime. Here I've set up a very simple function, fun1, and all it's doing is logging to the console the value of this. So if I were to invoke fun1, let's go ahead and see what we get. If I open up the console, we get the window object. Okay, so that probably isn't a surprise to you. We would expect to get the window object. Basically, this is being invoked in the global space. Since I'm using a browser, the global object is window. Therefore, technically, it's being invoked by the window object. We could also invoke it like this. That might make a little more sense of why the binding of this happens to be the window object. Now, what happens if I add another function here? And what this function does is basically invoke this function. That's all it's going to do. So let me comment out this one here. And then down here we'll invoke fun2. Now what is the binding for this? Well, once again, it is the window. Now you may look at this and say, well, in JavaScript, functions are objects. So why isn't this referencing the object here? Because that is calling it. Well, when we're talking about the binding of this, and we're referring to that it must show an object, we're talking about JavaScript objects, not specialized objects like functions or arrays or things like that. But we're talking about actual JavaScript objects. So in the case of functions, whenever a function is invoked, the value of this is going to be set to the global object. Now there's one case where that's not true, and that's if we're using strict mode. So if I come up here and put useStrict, basically what useStrict does is it tells the JavaScript engine to use a stricter form of syntax. So there's certain things that aren't allowed. One of those is the setting of this to the global object. So now when we do this, it comes back undefined. This is undefined. So if you use strict mode frequently in your code, then this isn't going to be bound to that global object, and that's something to be aware of. All right, now let's take a look at objects, because this is really where this is used when we're working with objects and we're trying to refer back to an object with this. So let's see how that works out. So I'm going to define an object here, obj1, and I'm going to put a name property just so we can keep track of the object a little easier. And then I'm going to put in a method. And all this method's going to do is the same as what we've done before. It's simply going to log this to the console. Now, when we do obj1.fun, we invoke that. You can probably guess what this is going to reference. It's going to reference this object because we are invoking it from the obj1 object. That's how we are invoking that method. So let's go ahead and take a look at that. Sure enough, that's the object we see, obj1. So using those rules, it's established at runtime, and it's determined by how it is invoked. And this is being invoked by that object. Okay, let's add to this a bit, make it a little more interesting. So I'm going to create a second object. Once again, I'm going to give that a name property so I know for sure what objects I'm referring to. And then we will do a fun method in this one. However, this time we're going to reference obj1.fun. All right, put some returns in here, so I move that code up a bit. Now, what is going to happen when we do obj2.fun, when we invoke that? What object will this refer to? This is an important exercise, I think. So let's save this, and let's go ahead and refresh. Notice that the second one, obj2. So let me go ahead and remove this one so we can keep everything straight. Do that again. It is obj2. Now, that illustrates the important point that it's not where the method is defined that's important, but it's how the method is invoked. And that's the rule we were talking about. It's how it is invoked that determines the binding of this. So since this is invoked based upon obj2, that is what this is bound to, is to this object, not this object. Now, let me do one more thing to help illustrate this point. I'm going to do a set timeout command. Now, if you're not familiar with set timeout, basically what it does is just execute some code after a certain length of time. Now, the first parameter that you pass in is the code you want to execute. So I'm going to say obj1.fun. That's what I want to happen. I'm going to do that after 1 second. That's expressed in milliseconds. So now, what is this going to be bound to? Remember, it has to do with how it is invoked. Well, how is this one invoked now? Let's go ahead and take a look and see what happens. And I've still got 2 going on here, so let me comment out that one so it doesn't confuse things. And as you can see, it comes back after a second as the window object. Now, why did that happen? Well, because now this code is being invoked by the window object. Set timeout is controlling what code is running. And set timeout is established in the global space. Therefore, the value of this becomes the global object. So you can see by these examples why determining this binding in JavaScript can sometimes be a little bit difficult, because it's not lexically bound. It's not how we enter the code that determines the value of this. It is how it is invoked. Now, we can also explicitly bind this. There are methods available to do that. And I want to make you aware of those as we conclude this discussion on this. But basically, call, apply, and bind are methods that allow us to bind this in a way we choose. Now, another structure to be aware of that affects the binding of this is an arrow function. Arrow functions practice lexical binding. And so it's a bit different than the kind of functions we've been using in here. Now, as you can see, understanding this could be a topic that could go on for a while. And in some of my courses, I spend quite a bit of time on this because it can be quite involved in JavaScript. It's not always a simple thing to determine. But once you understand the rules, like what we've talked about here in this topic, you are better able to understand and see why things are happening the way they are in JavaScript. And that's important. It's important to understand why the value of this changed with something you changed in your code. And you see that occur and you go, ah, I know that happens. And those experiences build up on one another and you begin to understand this in more and more depth. So those are the basic rules for this binding. All right, let's move on. Promises provide a powerful async pattern in JavaScript. Many APIs make use of promises, so it is definitely something you need to invest some time in learning. Now, understanding promises might not come easy for you, but don't give up on it. Also, there is a lot we can talk about with promises. So to simplify some things, we're going to talk about what promises are and how to use them. We won't look at creating promises. So let's first talk about what promises are. First thing we need to make sure we understand is that a promise is simply a JavaScript object. It is an object with properties and methods, and we use some of those methods to take advantage of promises. So first and foremost, it's an object. Second, this object represents the eventual completion or failure, because it could fail, of an asynchronous operation. So we now have an object that represents something that's going to happen in the future, something that will be completed in the future. And when the completion occurs, when this future event occurs, a value is provided. So a promise will always provide a value. So that is what a promise is. Now, let's start looking at these promises with code. First, I've set up a couple of promises on my own. I've made a couple of functions that return promises. So these functions are asynchronous. They do something without blocking code, and then when they're done, they will return a value. So I'm going to open up the console here. And this web page has access to a couple of these functions that I've created. So I'm going to call one of them first. Async function is what I've called it. Now when I press return, notice what we receive. As I said, it returns a promise. Here is the promise. And it is an object. As I open this, we can see information about that promise. If we open a prototype of the promise, notice what things we have available. We have some methods, then and catch. Those are two methods that are frequently used with promises. So these are the things we have access to when we're taking a look at this object. Now let me assign the promise that is returned to a variable. So I'll do that this way. Let promise equal async function. Now, as soon as I press return and then type promise, let's see what we get. Notice that it indicates the promise is pending. That means it has not been fulfilled yet. Now, if I type promise again, notice that it says it's resolved. And as we open it up, we see the status is resolved. We see the value that is returned is async function has resolved. So this is what when I set it up, this is the value I indicated should be returned when the async function is resolved. So we can see what a promise is. It's not some mysterious thing. It is basically a JavaScript object, but it has some things that allow us to work asynchronously. So since we have an idea what they are, let's look at using them. Now, the thing to keep in mind is that promises have become integrated into a lot of code that you will use. Now, the then method that I mentioned, that I showed as we opened up one of these objects, is how we make use of a promise. We talk about promises being thenable. You may hear that term in the JavaScript world. It's thenable, meaning we can use the method then with it. And this is how we need to think of it. We need to think of then as allowing us to make use of that promise, being able to determine when that promise has completed. So we call some function. It might be to connect to a server, to retrieve data from a website, to process some data. That function is set up to return a promise. We can then use that promise to wait for the code to finish and to then see the results, its value. Because it's asynchronous, other code will continue to execute and doesn't have to wait for the promise. Okay, let's look at that. I'm going to jump to Sublime now. Ignore these comments right here. We'll use those a little bit later. I'm going to set up the same command I did on in the console. Let promise equal async function. This is one of the functions I set up that returns a promise. Now, when we did this in the console, we then took a look at the promise a bit later and saw that it was resolved. You can think of that like an event. We can use that then method I indicated to respond when the promise is resolved. And I really should say or when it fails, because then would allow us to respond to both. But either way, we can use then to respond to this promise. So let me look at that. Let's add promise.then. Okay, so here's the then method. And this will allow us to respond to that. Now, we want to do something when it's resolved. So in order to do something, we can pass a function into then that is invoked once the promise is resolved. We could actually pass two functions. The first function we pass in would be invoked when it's resolved. The second function would be invoked if there is an error. Now, some of you may be saying, well, if we're passing a function in, isn't that similar to a callback? Yes, yeah, it is. When the promise is resolved, it's going to invoke that function. So yes, that's similar to a callback. We're not eliminating callbacks completely. We're just using them with promises now, which make them much better to use in an asynchronous fashion. So let's go ahead and set that up. I'm going to enter a function, and for this anonymous function, I want a variable. This is the value that is going to be returned by the promise. Remember, I said the promise will return a value. That is the value there. And we're going to do something with that value. Now, what are we going to do with it? Well, as I do in most of my tutorials, I'm going to keep it simple. We're just going to log to the console at this point. Now, let's make sure that we concatenate that value so we can see what it is. Okay, so I'm putting the text yay in there, and then we'll also get whatever the value is returned by the promise. So let's go ahead and save that, and let's jump out to the console and refresh. Nothing is happening. We're not seeing anything on the console. Now, finally, when that function has completed, we get yay. This is the value I put in. Here's the value that's returned by the promise. Async function has resolved. When I set up the promise, that's the value I indicated should be returned. All right, now just to make sure that you are aware that this is asynchronous, let me add a console log statement down here. All right, let's see if this truly is asynchronous. If it is asynchronous, this line should print to the console right away. And then later, once the promise is complete, we'll get this log statement. So let me save that, and let's run it again. So the code is asynchronous. We get that right away. The promise is still working. The promise is now resolved. It returns. The then method, which we attach to it, allows us to invoke that code, that function that we passed in, and that code runs whatever it needs to do. In this case, all we do is log to a console. Now, that is a single promise. Now, one of the issues with callbacks is what we call callback hell, where you start getting a lot of callbacks together, and it gets very unwieldy. It gets difficult to manage. So let's add a second promise. Let's, inside this code, let's say once this is done, once it is completed, we want to do something else. Okay? So we're waiting on this to complete, and then we're going to do something else. And this second function we want to invoke is also a promise. It returns a promise as well. And so we want to be able to respond to that. So the way we do that is we enter return. We have to enter the word return, otherwise we won't be able to respond to this second promise that we're creating here. So we will then call async function 2. This is another function I've set up that returns a promise. Now, how are we going to respond to this second one? Now we can save this and we can invoke it, and it runs. But how do we respond to the second promise? Well, here's one way. We can assign that second promise to another variable. And then once it's assigned to another variable, then you've guessed it, we can then use a then, the then method, to respond to it. So in order to do something, once that then fires, we need to pass in an anonymous function. And let's just log to the console again. And let's say second promise. And then let's also attach a value as well. Let's see what value this promise returns. Okay? So there we're responding to the second promise. Let's go ahead and save that and take a look at it. This code is asynchronous. That obviously shows first. The first promise is resolved. It then invokes the second one. And the second promise is resolved, and we can see the values are passed from both of those. We get AC function 2 is done. That's the value passed from the second promise. Okay, so we have a couple of promises here, but we can clean this up. This can be done better. So let's clean it up. We're declaring a bunch of variables, and we really don't need to do that. Promises are structured so that we can chain them together. But chaining is used quite frequently with promises. That's the way to help them remain clean. Let's don't assign stuff to a variable. Let's just chain everything together. So first we invoke this first async function. It's going to do something that we want that takes some time, so we want to do it asynchronously. And it returns a promise. So we can immediately set up the then method on that promise that is returned. We don't need to assign it to a variable and then use the then method on it. We can do it right away like we've done here. Well, this is going to return a promise as well. We have the return statement here, and so when this anonymous function is invoked, it will return a promise as well. It calls this function that will return a promise. And so we can immediately associate then with that promise that is returned. So here we've chained things together. Now, the way I like to do this which I think makes it more readable, is I put the dots on the next line. And that makes it easier to read down through what's going on, so I can see the different things that's going on with these chained promises. All right, let's go ahead and save that. We'll take a look at it again, make sure it's working. All right, so it's all working. We've got it chained together. It makes it look cleaner. This is how you are going to see promises if you're looking at other people's code. Now, one thing I should mention at this point, you may also see arrow functions used a lot with these. Arrow functions work great, especially if you just have a single line that you're working with. Not always, but you may see arrow functions with them. Now, let's take a look at a real-life example. So let me get rid of this code. I'm going to use this website here. This is WordNick. I saw in another tutorial on promises that I was watching once, I saw them use this particular website, and I thought it was interesting. Basically, this website has an API, as you can see down here, and allows us to retrieve words, definition of words, and that type of thing. Well, we're going to do all of that with promises. Okay? So here in Sublime, I'm going to uncomment these variables that I've already set up. Basically, this has the URLs that I need to use in order to retrieve data from that website. Now, I'm going to use fetch to retrieve this data. Now, if you're not familiar with fetch, don't let that confuse you too much. If you've been in the JavaScript world for a while, fetch basically replaces XML HTTP request. And it's so much simpler. So much simpler to use. Basically, what we can do is we can go to a website and fetch data. Great name for it, right? Fetch. So here's what that command will look like. Fetch, we're going to go to this URL. We're going to get a random word. So I'm adding that on the end. And then I need to add my API key, which allows me to use the website. I would rather no one use my API key. So if you'd like to try this on your own, go ahead and request your own API key from the site. Now, fetch returns a promise. That is what it does. So when we use fetch to go out and get something, what gets returned is a promise. So we then need to respond to that promise. The way we do it, then, and inside of then, we put our function that's going to be invoked. And we're going to get a response from the website, so I'm going to place that into the response variable. Then I'm going to assign it to this variable in case we need to use it again. And then let's log it to the console, just so we can take a look at it. So we've done those two things. Let's go ahead and save it. And let's refresh and see what we get. Looks like I've got a problem with my response. I didn't spell it right here. Save that again. Jump out. All right, here's our response from the website. It gives us some information. But something fetch provides for us that will allow us to work with this information more easily is it has a JSON method that will convert it to an object that we can work with. And this JSON method returns a promise as well. So we want to use the JSON method on this response object. So here's how we would do that. And since it returns a promise, and we want to act on that, we need to return that promise. And we just do that. Return response.json. And since it returns a promise, we want to act on it. Let's go ahead and do a then. And this time we will capture the data. This will be an object that we can work with. Let's go ahead and log that to the console. And I'm going to comment out this one so we just see the actual word. Once this is converted to JSON, which what happens here, we get that object. We then can retrieve the word from the object by using .word. So let's take a look at that. Save that, jump out. So that's the word we retrieved. It's a random word, so if we do it again, we get a different word. And a different word, and so on. Okay. Well, now we've got a word. We could actually go back to that website and get the definition of it. The API allows us to do a lot of different things with the words we retrieve, and one is to get a definition. So let's go ahead and put the statement that will do that. We'll use fetch again. So what's fetch going to return? A promise. So here it is. Here's our URL plus the word plus definitions plus the API key. And that's going to return a promise for us. So we want to do something with that. So we use then, and then let's set up the code. We're going to get a definition. And then what are we going to do with that definition? Well, it's going to return JSON text, which we need to convert to an object. So let's do return def.json again. That's going to return a promise. So now you can see we're chaining a bunch of things together. And this time we can log to the console the definition. Like this. See how we're chaining these together? Now imagine what this would be like with callbacks. It would be a callback inside a callback inside a callback. It would become a real mess. This is much easier to read through when it's structured this way. Plus it adds other benefits. Promises have other benefits. It's not just visually it's better, but it functions better as well. All right, let's go ahead and save this and see what we get for the definition. Now notice how the definition comes in an array. That means we have multiple definitions. Third person singular, simple, present, indicative, form of discover. That's what discovereth means. I didn't even know that was a word. Anyway, so we could further use this to pull stuff out and work with it. It's that type of idea. All right, now this has been a long tutorial. I apologize for that, but there's a lot to talk about with promises. So one more thing before we're done here. I mentioned that with promises, each then method can have two functions. The first function, that is if the promise is resolved positively. The second function, if we passed in a second function, it would be if there is an error. So we could do a comma, then do a second anonymous function, and that would respond only if an error occurred. However, that would be really messy if we did that for every one of these. Well, as we're looking at the promise object, we saw that its prototype had a catch method. Well, what do we use that catch method for? Well, we can use it to catch any error. Really nice way to deal with errors. And so at the end here, I'm going to put a catch, and then I'm just going to enter a function that will be invoked if there is an error, and we'll just log that error to the console. And that will take care of any errors that might happen. One more thing before we're done, let me just do a console log statement so we can see this is asynchronous. Okay, save that. Let's run it again. We see that it's async code. Overticks is the word we get. We could take a look at the definition. Now, let's see what would happen if we had an error. I'm going to go up here and just change the URL so that we get an error. Type error, failed to fetch. So see here we're getting the error for the catch method of promises. So we've covered a lot. You may need to watch this again. And if so, I'd encourage you to do so. It is a good idea to get a good handle on how to use promises. All right, let's move on. We have come to the end of the 11 concepts. 11 concepts are pretty arbitrary. There are many important concepts in JavaScript, but these 11 are definitely crucial. So we first looked at scope and dug into that, and then we built on that with hoisting. And then we talked about a very important concept in JavaScript, that objects are everywhere in JavaScript. And that's an important thing to remember. Prototypal inheritance, the type of inheritance that JavaScript practices for its objects, is crucial to understand. We dealt with that with a couple of videos. Then we talked about higher order functions. JavaScript has higher order functions that makes many things that we do in JavaScript possible. One of those being callbacks. And we dealt with callbacks and the importance of callbacks. Even though there have been additional asynchronous patterns added to JavaScript, callbacks are still critical and important. We dealt with IFEs, immediately invoked function expressions. Those are found throughout JavaScript code. Closure, such a critical concept in JavaScript. I feel closure is one of the most powerful things that JavaScript has to offer. That's hard to say because there are a lot of things that it has to offer, but closure really is a concept that I draw on quite a bit. Then the module pattern. Very important pattern for developing, making sure that code is self-contained and that we're avoiding conflicts with variables and functions. Understanding this is simply important because it's not a straightforward idea. And so it can cause confusion and it can affect what we do with our code. And then finally, promises, an important asynchronous pattern. And as I considered promises, I thought about async and await, which is a new asynchronous pattern. But understanding promises is necessary to understanding any of the other async patterns. And so that's why I chose promises. So those are the 11 concepts. I think the important thing is to understand these concepts well and continue learning JavaScript. That's one thing I've always felt is crucial, is never stop learning JavaScript. You need to always improve on the skills you already have. All right. Thank you for joining me in this course, and I hope you found it helpful.